Imagine a massive retail chain, right? And they sell, I don't know, just 50 fewer baby cribs this month.
Right, just a tiny blip.
Exactly. Like maybe it rained a lot and fewer parents went out shopping. But by the time that 5% drop in sales ripples all the way up the global supply chain, the factory making the raw plastic for those cribs slashes their production by staggering 80%.
Yeah, it's wild. It is this mathematical phenomenon that destroys billions of dollars in inventory. And, well, today, we are figuring out how to stop it.
It's the ultimate chaotic chain reaction.
Yeah.
You think you're operating this predictable, well-oiled machine, but you're actually trying to predict the collective behavior of millions of people.
While navigating global logistics, no less, it's less like building a rigid bridge and much more like trying to steer a massive cargo ship.
Right.
You turn the wheel now, but the ship doesn't actually change direction for like 3 miles. You have to predict where the water will be, not where it is right now.
And that is exactly why we are here today. Welcome to this deep dive. Whether you are prepping for a high-stakes meeting on your operations, or you are just insanely curious about the hidden forces driving the global flow of goods, you are in the right place.
Yeah, absolutely.
Our sources today are coming straight from Module 3, Section C of the M3SC CPI materials, and our mission for this deep dive is to explore the fascinating and honestly kind of maddening world of forecast performance.
It really is maddening.
We're going to figure out how supply chains attempt to predict the future, the incredibly specific ways they measure when they get it wrong, and how these massive chaotic ripples can actually be prevented. So, okay, let's unpack this.
To really understand the mechanics here, we kind of have to start with the baseline reality established in the text. And it's a truth that makes a lot of executives deeply uncomfortable.
Well, I bet. What is it?
Forecasts are wrong most of the time.
I always find that reality so jarring. Like, if these predictive models are literally always wrong, why do massive corporations spend tens of millions of dollars on them?
Well, because the goal of forecasting isn't actually perfection. I mean, it's about reliability.
Reliability over perfection.
Exactly. If you steer that cargo ship, you know the waves are going to push you off your exact line. But you need to know exactly how far off the line you usually drift and what direction and, whether that drift is something you can build a buffer for.
So we use them to set baselines.
Right. We calculate how much safety stock we need to survive a disruption, and we use it to detect if our planning teams have a systemic bias. The evaluation of the forecast is arguably more important than the forecast itself.
Because it forces the planner to stand by their results.
Yes. It makes them declare their error margins.
Okay, so since we know the numbers on the page are flawed right from the jump, we have to figure out how much we can actually trust them. We need a report card for our predictions.
Which means measuring the error mathematically. The most foundational metric of error in supply chain operations is deviation.
Right.
The math is super straightforward. It's just actual demand minus the forecast.
Simple enough?
Yeah, so if you predicted you'd sell 100 units and you actually sold 110, your deviation is a positive 10. You underforecasted.
And if you sold 90, your deviation is a negative 10, meaning you overforecasted.
Got it.
But wait, I was looking at the map and the source material, and a massive blind spot immediately jumped out at me.
Oh, yeah.
Yeah. Let's say my forecast is over by 10 units in January, so that's a negative 10 deviation. Then in February, I'm under by 10 units, giving me a positive 10 deviation.
Okay, tracking with you.
If leadership asks for my average error over those 2 months, those numbers just cancel each other out. It makes my department look perfectly accurate with the 0 average error, when in reality, we failed both times.
Exactly.
I mean, we had expensive excess inventory 1 month and catastrophic stockouts the next.
And that exact trap is what ruins amateur supply chain plans. If you simply average raw deviations, the positive and negative signs completely mask the true volatility of your operation. You can have wildly out-of-control forecasting that mathematically averages out to 0 error. That is why industry standards dictate dropping the plus or minus signs entirely. We have to look at the absolute truth of the error.
So a negative 10 error and a positive 10 error are both simply recorded as an absolute error of 10.
Correct. We need to see the full operational impact regardless of which direction it swung. And this gives us one of the most critical metrics in the field. It's called MAD.
MAD, mean absolute deviation.
Right. You take the sum of all your absolute errors over a given period and divide it by the number of periods. So if you were off by 10, then off by 15, then off by 5.
You add those up to get 30.
Exactly. Divide by the 3 periods and your MAD is 10 units. It basically tells warehouse managers, hey, on average, our prediction is going to miss reality by 10 units.
Having that tangible number completely changes how a warehouse operates. Instead of going off gut feeling, you can go to the floor and say, we usually miss the mark by about 10 units, so let's physically keep 10 extra units of safety stock on the shelves.
It builds a mathematical shock absorber. And, while MAD is the heavy lifter, the text drops a few other specialized tools too, like M3SC, which is mean squared error.
Okay.
This involves taking your errors and squaring them before averaging.
Wait, squaring the error seems like a brutal penalty. Why make the numbers look worse than they actually are?
Because a massive miss is exponentially more destructive than a minor wobble. Squaring the errors mathematically penalizes a forecast for having massive wild swings in a single month rather than small, manageable errors spread out over time.
Oh, that makes total sense. One massive stockout could lose a major client forever.
Yeah, whereas 10 tiny errors might just mean a little extra paperwork. Then you also have MAPE, mean absolute percentage error, which translates the error into a percentage.
Right, because missing by 10 units is a total disaster if you only sell 20 units a month, but
it's an incredible triumph if you sell 10,000 units a month.
exactly. You need MAPE for the executive dashboard so they can understand the actual scale of the miss.
And understanding that scale ties directly into another vital concept from the text, allowable item tolerances. In the industry, they use the acronym WAIT, W-A-I-T.
Within allowable item tolerances.
Right. It basically asks, is this error a hit, meaning within tolerance, or a miss, meaning it's problematic?
It's drawing a line in the sand. It tells the business, okay, we can absorb this friction without breaking a sweat, or, uh-oh, this is going to cascade into a major problem.
Exactly. So identifying whether your errors are hits or misses is step 1. Step 2 is diagnosing the mechanics of why you are missing.
Because once we calculate our error, using MAD, we have to categorize the behavior of that error.
Right. Are we consistently wrong or just randomly wrong? This separates bias from random variation.
Okay, I have an analogy for this. Think of playing darts at a pub.
Okay, I'm listening.
Random variation is having a really tight cluster of darts grouped all around the bullseye. You're a little high on one throw, a little low on the next, maybe a bit right, but you are centered.
Right, you're hovering around the target.
Exactly. Over time, your average throw is right in the middle. But bias, on the other hand, is consistently throwing your darts high into the left. Every single time. Your grouping might be tight, but it's completely in the wrong place because you're fundamentally misreading the board, or maybe there's a heavy draft in the room you're ignoring.
That dartboard visualization perfectly captures the underlying mechanics. Random variation is unbiased. The root cause is just the inherent noise of the physical world.
Like a slight weather delay or a single customer changing their mind.
Exactly. In operations, random variation is just background static. Over time, the cumulative deviation stays near zero because the highs and lows balance out naturally.
But bias is dangerous.
Very dangerous. Bias indicates a fundamental flaw in the system's logic. It's a consistent deviation from the mean in one direction.
So it implies your data is poisoned, or your strategy is entirely disconnected from reality.
Yeah, like maybe your sales team is incentivized to be overly optimistic, so they always predict a 10% growth that the market never actually delivers.
Oh, wow. Yeah.
Or your algorithms are training on outdated consumer habits. If bias infects the system, actuals and forecasts severely diverge over time.
So you aren't just overproducing one month, you're overproducing every single month.
Which leads to massive cumulative errors. Warehouses physically overflowing with unsellable goods, capital trapped in dead inventory.
But how does an operations team actually spot that bias?
Yeah.
I mean, if you're managing a global catalog of 10,000 different products, manually finding the heavy draft blowing your darts to the left seems impossible.
Well, what's fascinating here is that the math provides an incredibly elegant alarm bell for this. It's called the tracking signal.
The tracking signal.
It's a one-number bias assessment. You calculate it by taking the algebraic sum of forecast deviations and dividing it by the MAD.
Wait, algebraic sum. So we're putting the plus and minus signs back in for this specific calculation.
Yes. Notice that key word.
Ah, I see how that mechanism works. If the system is just experiencing normal random variation, the positive and negative errors will cancel each other out over time.
Right, making that top number hover right around 0.
And 0 divided by anything is 0. So a tracking signal near 0 tells the control room that everything is balanced.
Exactly. But if you are consistently over-forecasting, that top number will compound. It grows larger and larger in the negative direction.
So it's literally tracking the drift.
Exactly. Let's say your sum of deviations hits -80 and your AD is 28. Your tracking signal drops to -2.83.
And that's bad.
Standard operating procedure usually dictates that if your tracking signal drifts beyond positive or -3 or 4, a literal alert goes off in the software.
Oh, wow, an actual alarm.
Yeah, you don't just stare at it. You freeze production, investigate the root cause, and pivot to safety stock until the biased forecast is repaired.
So what does this all mean? Like, what happens out in the physical world when an organization ignores that tracking signal alarm?
It gets ugly.
When fundamentally biased data is allowed to travel upstream from a retail store all the way through the manufacturers back to the raw material suppliers.
Yeah. When bias propagates upstream unchecked, it triggers what is arguably the most famous and destructive force in supply chain management, the bullwhip effect.
The bullwhip effect.
It's defined as an extreme change in the upstream supply position generated by a very small change in downstream demand.
This brings us back to the crib example from the research, which illustrates the sheer violence of this phenomenon perfectly.
It really does. Let's walk through the mechanics of how that small drop creates a shockwave.
Okay, let's do it.
So imagine a multi-tier supply chain for baby cribs. At the very end of the chain, facing the consumer, is the retail store. Behind them is the crib manufacturer.
Right.
Behind them is supplier 1, making the mattresses. Then supplier 2, fabricating the fabric covers.
Yeah.
And finally, supplier 3, deep in the industrial supply base, producing the raw plastic liners.
Okay, so 5 links in the chain.
Exactly. Now, in period 1, the system is in perfect harmony. Retail demand is 1,000 cribs. The store orders 1,000. The manufacturer builds 1,000, and every supplier down the line produces exactly 1,000 parts.
Then period 2 hits, and we see that 50-unit drop we talked about at the start.
Right. Retail demand dips to 950.
Which is a completely standard 5% fluctuation at the cash register.
But the crib manufacturer doesn't see the cash register data. They operate entirely off the purchase orders they receive. When the store's order drops to 950, the manufacturer looks at their own warehouse, notices they now have a little extra inventory sitting around from the previous month, and they panic.
So they don't just drop production to 950.
Nope. They overcorrect and slash production to 900 to burn off their excess stock.
They are reacting to their inventory, not the true demand.
Precisely. Now the shockwave hits supplier 1, the mattress maker. They see orders suddenly drop from 1,000 to 900.
That's a 10% drop for them.
Right. They assume the market is entering a downward trend, check their own safety stock, and panic even harder. They drop their production to 800.
And supplier 2, the cover maker, receives an order for 800. But because of their minimum order quantities, they can't just make 800 efficiently, so they slash their production down to 600.
And finally, the shockwave slams into poor supplier 3, making the raw plastic liner.
The furthest upstream.
Yep. They see orders completely collapse from 1,000 down to 600. Lacking any context, they assume the entire crib market has imploded.
Oh, man.
To stop the financial bleeding, they crash their production all the way down to 200 units.
It's a mathematical tragedy. A harmless 50-unit drop at the retail store caused an 800-unit crash at the raw material level.
An 80% slash in production.
Fueled entirely by a 5% drop in sales.
That is the physics of the bullwhip. A small flick of the wrist at the handle of the retail store creates a massive, violent snap at the tip of the whip, which is the raw materials.
And the devastation truly lands in period 3, when retail demand inevitably stabilizes back at 950, but supplier 3 only has 200 plastic liners left in existence.
The entire chain starves. The factories shut down, the shipments stop, and the retail store ends up with empty shelves.
So what actually causes this? I mean, we just saw the numbers, but what is the human element here?
Well, the text outlines exactly what drives this self-inflicted disaster. The primary cause is what we just witnessed, updating forecasts based on upstream orders rather than actual end-user demand.
The suppliers are essentially playing a giant game of telephone.
Exactly, and the message gets distorted at every step. Other major culprits include order batching, like For administrative ease, a retailer might wait until the end of the month to place one massive order instead of small weekly ones.
Which hits the manufacturer like an artificial tidal wave.
Right. And then there are price fluctuations. If marketing runs a massive discount, they artificially spike demand.
That sends a gigantic ripple upstream, causing factories to go into overdrive, only for demand to completely evaporate the next month when the promotion ends.
Because consumers have stockpiled the product, we also see rationing in gaming. If there's a perceived shortage, retailers will artificially inflate their orders, requesting triple what they actually need, just hoping to get a fraction of the allocation.
Which completely destroys the manufacturer's forecasting algorithms.
Completely. So, to control this bullwhip, the texts suggest a very specific shift in strategy. Rely less on forecasting.
Wait, really? Rely less on forecasting after we just spent all this time establishing how important it is.
Yeah, I know. But the idea is to utilize pull-based systems like demand-driven MRP, which triggers production based on actual consumption, not future predictions.
Okay, so reacting to what's happening now.
Right. Plus, taking smaller and more frequent orders, agreeing on fewer promotions, and utilizing vendor-managed inventory, or VMI.
VMI is a fascinating mechanism. The retailer essentially hands the keys to their warehouse over to the supplier. The supplier directly monitors the retailer's inventory levels and automatically replenishes it based on actual daily sales. So the purchase order step, the exact moment where the panic and distortion happen,
It's completely removed.
here's where it gets really interesting, though. If the ultimate cure to the bullwhip effect is shared data, total transparency, and working together, how do massive competing corporate entities actually achieve that without constantly arguing?
That is the big question.
Getting two departments in the same building to share their metrics without turning it into a turf war is notoriously difficult. Why on earth would a protective, multi-billion-dollar retail chain hand over their live, proprietary point-of-sale data to a manufacturer?
Especially since suppliers historically use that exact data to game pricing negotiations.
It sounds like a corporate nightmare.
In a traditional adversarial supply chain, it absolutely is a nightmare. But the industry has developed a structured framework to solve this specific friction. It's called CPFR, Collaborative Planning, Forecasting, and Replenishment. It fundamentally changes the relationship from a zero-sum negotiation into a positive-sum partnership.
The framework breaks this down into 4 specific phases. But I want to look at the actual mechanisms. How do entirely different companies actually sit at a table and do this?
It starts with phase 1, strategy and planning. Crucially, they don't start by talking about orders or pricing. They start by creating a joint business plan.
Okay.
The executives sit down and formally establish the rules. They decide exactly what data will be shared, how their massive software systems will technically interface, and what the overarching market goals are.
They are aligning their key performance indicators so that both companies win when a product sells, rather than the supplier winning just because the retailer bought too much.
Exactly. And once that trust is codified, they move to phase 2, demand and supply management. This is where the magic happens.
Because they're looking at the same numbers now.
Right. Instead of the manufacturer guessing what the retailer will sell and the retailer guessing what the manufacturer can build, they look at the shared point-of-sale data together.
Oh, wow.
They collaboratively build a single, unified sales forecast. And from that one forecast, they generate a joint order plan.
So the manufacturer knows exactly what to build, and the retailer knows exactly what they're going to receive. The friction is engineered out of the process.
Which streamlines phase 3, which is execution, actually generating the orders and fulfilling them. It becomes a coordinated ballet rather than a series of panicked fire drills.
But the true test of CPFR happens in phase 4, analysis.
Yes, because eventually a truck is going to break down or a port is going to strike. Reality will always intrude.
And when it does, traditional supply chains descend into finger-pointing.
Oh, instantly. The retailer blames the supplier blames the retailer. But in CPFR, they practice exception management.
Exception management.
They look at the failure together. They review joint scorecards and ask, did our shared forecast fail or did the logistics network fail? How do we adjust the joint plan?
It completely starves the bullwhip effect. The bullwhip relies on blindness and delayed reactions. When everyone from the raw material supplier to the retail floor can see the exact same true demand signal in real time.
The shockwaves simply cannot form. If we connect this to the bigger picture, CPFR shifts supply chain relationships from adversarial to collaborative, maximizing efficiency for everyone.
And whether you are managing global logistics or just trying to get your marketing and sales departments to stop fighting, CPFR is a masterclass in breaking down silos through shared data.
It really is.
What an incredible journey through the hidden architecture of the global economy. To quickly recap the ground we've covered, we learned to embrace that forecasts are inherently wrong and how to measure that wrongness with absolute deviation and MAD.
Right.
We diagnosed the difference between random noise and the systemic danger of bias using tracking signals. We survived the chaotic bullwhip effect, and we saw how the structured transparency of CPFR brings everyone to the same table.
It's a complete paradigm shift. The materials actually point out that the best forecast uses actual demand, and that modern demand-driven enterprises strive to rely less on forecasting altogether.
Which brings up a final thought to mull over. If forecasts are inherently flawed and act as the root cause of the bullwhip effect, maybe the ultimate goal of a world-class business isn't to build a better crystal ball to predict the future.
Maybe not.
Maybe the true goal is to build a system so fast, agile, and collaborative that it doesn't even need to predict the future. It just reacts perfectly in real time.
A fascinating thought.
If the cargo ship is going to drift, make sure you know exactly how to measure the waves. Thank you so much for joining us on this deep dive. Take a close look at your own industry and see if you can spot the crack of the bullwhip effect hiding in your daily operations. We'll see you next time.